So this exercise is about evaluating the truth of a formula. So consider the following formula. P and Q implies not P or Q. And the exercise is to evaluate the truth value of this formula. Now, in order to evaluate the truth value of this formula, you need to be given a valuation. So here is the valuation that I'm giving you. So the valuation assigns to P the truth value 0, it assigns to Q the truth value 1, and it assigns, well, there are no other formulas. We're just P and Q, so that's enough. So the valuation is just restricted to all the atomic formula. Okay, so we are ready now to assess the truth value of this more complex formula up here. So I'm gonna write it down again. And the first thing to do here is to break it down in a tree-like format. So we have P and Q here, we have not P or Q here, and these can be further broken down into P and Q, and P or Q, and then again P and Q. So this is our tree for the formula up here. And we can assign truth value to the atomic formulas right here according to what we are given here in the valuation. So we can assign 0 to P and 1 to Q. So 0 to P, 1 to Q, so 0 to P and 1 to Q. Now, once we have done this for the atomic formula, we can move one step up and assign truth value to the more complex formulas following our truth tables. So if P is 0 and Q is 1, the truth table for the conjunction tells us that P and Q should have value 0. Instead, if P is 0 and Q is 1, the truth table for the disjunction, in this case, tells us that we should assign value 1 to P or Q. The negation, right up here, flips the truth value. So since we have 1 for P or Q, we should have 0 for not P or Q. So I'm writing 0 up here. And we're almost done. So now we need to think about the truth value of this entire formula. So P and Q implies not P or Q. Since the antecedent of this formula, namely what comes on the left-hand side of the arrow, has truth value 0, then the entire formula here, because of the truth table of the implication of the arrow right here, gets value 1. And so we can say, in fact, that relative to this valuation V that has been defined up here, the formula P and Q implies not P or Q. That's in fact true relative to this valuation V, and we are done.